12,800 years ago, the Earth was finally thawing. After 100 millennia of ice, the planet was warming. Grasslands were expanding, and the future seemed predictable. Then, within a human lifetime, the world collapses into winter. Forests of spruce and pine were marching northward, following the retreating ice. They supported immense biomass, herds of mammoths numbering in the thousands, and giant ground sloths moving through landscapes that hadn't seen sunlight in an eternity. This chart tracks the stability of that warming trend. For thousands of years, the climb is steady. Then, the data hits a cliff. In some areas, the temperature falls 27 degrees Fahrenheit. Geologically speaking, it happened overnight. Conventional climate models struggle to explain this speed. The planet had massive thermal momentum pushing it toward warmth, yet something powerful enough to break those feedback loops threw the entire system into reverse. Evidence for this reversal first appeared in Scandinavian bogs. Researchers found layers of warm weather birch pollen suddenly replaced by this Arctic plant, Dryas octopetala. Its presence meant the regional climate had rewound 10,000 years in a matter of seasons. This diagram shows how Greenland ice preserves that moment. Snow traps air bubbles, which act as time capsules of the ancient atmosphere. By measuring the ratio of oxygen isotopes in these paper-thin layers, scientists can calculate exact temperatures from 12 millennia ago. The ice confirms the pollen story. Glaciers that had been retreating for miles every decade stopped, then surged back south. In Scotland and North America, ice sheets began crushing the very forests that had just colonized the former tundra. These physical records transformed a strange botanical observation into a documented planetary event. With the scale of the cold established, the focus shifted to the physical mechanics capable of stalling a warming world. Reversing a global warming trend requires a massive shock. As ice melts and dark ground is exposed, the Earth absorbs more heat, creating a self-reinforcing loop of warmth. Breaking that loop requires a force that can overwhelm the planet's energy budget. One suspect lies in the center of North America. As the Laurentian ice sheet thinned, it held back Lake Agassiz, a freshwater reservoir larger than all the modern Great Lakes combined. If an ice dam failed, it would have released a continent-sized flood into the Atlantic. This diagram illustrates the Atlantic Ocean conveyor belt, which moves tropical heat toward the poles. This system relies on heavy, salty water sinking in the North Atlantic. If that salt is diluted by a sudden pulse of fresh lake water, the water becomes too light to sink. The pump stops, and the northward transport of heat shuts down. Another theory points to the black mat, a thin layer of sediment found across continents. It contains soot from widespread fires alongside nanodiamonds and iridium, elements rarely found on Earth's surface but common in asteroids. This suggests a fragmented comet may have exploded in the atmosphere, dimming the sun with a veil of ash. A third possibility involves the Locher Sea eruption in modern Germany. This massive volcanic eruption occurred right as the cooling began, potentially injecting enough sulfate aerosols into the stratosphere to block solar radiation and kickstart a cooling cycle. Whether the trigger was water, fire, or ash, it hit a vulnerable tipping point. Once the North Atlantic cooled and sea ice expanded, the wider surface reflected even more sunlight back into space, locking the northern hemisphere into a 1,000-year feedback loop of cold. The shift decimated the megafauna. In North America, 35 categories of large mammals, including mammoths and horses, vanished from the record. This collapse reached the humans who tracked them. The Clovis culture, defined by these fluted spear points, effectively disappears from the archaeological record. Across the ocean, the cold snap brought a different crisis. In the Levant, rainfall patterns shifted, and the wild cereals that human groups relied on began to fail. For the first time, the landscape could no longer support traditional foraging. This stone grinding tool marks a shift in survival. Facing drought, the Natufian people began deliberately tending wild grasses, weeding, watering, and selecting seeds to ensure a harvest. They moved toward controlled food production to hedge against the environment. Tending crops required staying in one place, which anchored communities to specific plots of land, providing a predictable calorie source as the climate remained unstable. At the same time, groups in southeastern Turkey began building Göbekli Tepe, They carved and raised these T-shaped pillars, some weighing 50 tons, creating a massive ritual center. It was an unprecedented investment of communal labor, built right as the climate reached its most erratic point. These shifts toward farming, permanent building, and organized labor coincide directly with the 1,000-year freeze. The cornerstones of what we call civilization took root exactly when the old, mobile ways of life were no longer enough to stay alive. 11,600 years ago, the freeze ended as abruptly as it began. Greenland ice cores showed temperatures rocketed up 10 degrees Celsius. The ocean conveyor belt revved back to life, and the glaciers began a final, rapid retreat. The planet entered the Holocene, a 10,000-year plateau of climatic calm. Compared to the violent swings of the Ice Age, this new era was remarkably steady, providing the reliable seasons needed for agriculture to expand globally. This stability allowed for surplus, and surplus allowed for everything that follows: the rise of cities, the birth of written language, and the specialization of labor. For the first time, human groups could plan for a future that looked like the past. Nearly every human achievement we recognize exists because the Earth's climate decided to stop lurching and start lingering. We are living through a rare stroke of geological luck. But the system that stalled 12 millennia ago is still in operation. The Atlantic meridional overturning circulation continues to carry tropical heat north, and modern measurements show it is currently slowing down. This chart shows the measured deceleration of that Atlantic current over recent decades. As the Arctic warms and Greenland's ice melts, a new pulse of fresh water is entering the ocean, diluting the salt and slowing the pump that maintains our current climate. This illustrates the concept of a tipping point. Complex systems like ocean currents can absorb stress for a long time, adjusting and flexing, until they hit a threshold where the feedback loops flip and the entire system snaps into a new state. The Greenland ice cores prove that climate doesn't always move in a slow, gradual arc. It operates with trapdoors. When certain invisible lines are crossed, the environment we built our cities around can reorganize itself in less than a generation. The younger Dryas serves as a rehearsal for how quickly a stable world can end. It reminds us that our civilization is tuned to a lucky pause in a restless planet, a pause that the ice shows can be revoked at any time.